Welcome. Today we're diving into the world of biosensors and their crucial role in environmental monitoring. Biosensors are analytical devices that combine a biological component with a physicochemical detector. They're designed to detect and measure specific substances in our environment, such as pollutants or toxins. As concerns about pollution and ecosystem health grow, biosensors have become essential tools for scientists and environmentalists. In this video, we'll explore how these innovative devices work, their applications, and why they're transforming the way we monitor our planet. Let's start by understanding what biosensors are and why they matter. Biosensor is a device that uses a biological element like enzymes or antibodies to detect chemicals or biological molecules in the environment. This biological element interacts with the target substance, and the resulting signal is converted into readable data by a detector. Biosensors are highly sensitive and can provide real-time information about environmental conditions. Their ability to detect even trace amounts of pollutants makes them invaluable for monitoring air, water, and soil quality. Now let's look at the main components that make up a biosensor. Biosensors consist of three main parts: the biological recognition element, the transducer, and the signal processor. The biological element, such as enzymes or antibodies, specifically binds to the target substance. The transducer converts this biological interaction into a measurable signal, often electrical or optical. Finally, the signal processor interprets the data and displays it in a user-friendly format. Each component plays a vital role in ensuring the biosensor's accuracy and reliability. Understanding these parts helps us appreciate how biosensors can deliver precise environmental data. Biosensors operate by bringing the biological element into contact with the sample, such as water or air. When the target substance is present, it binds to the biological element, triggering a response. The transducer then converts this response into a signal, which is processed and displayed. This process allows for rapid and accurate detection of environmental contaminants. The beauty of biosensors lies in their ability to provide real-time monitoring, enabling quick responses to environmental threats. Next, let's explore the types of biosensors used in environmental monitoring. There are several types of biosensors, each designed for specific applications. Electrochemical biosensors measure changes in electrical signals, while optical biosensors detect changes in light. Piezoelectric biosensors sense changes in mass or vibrations. Each type has its strengths depending on the target substance and the environment being monitored. For example, electrochemical biosensors are often used for water quality testing, while optical biosensors excel in detecting air pollutants. Understanding these types helps us choose the right biosensor for each environmental challenge. Electrochemical biosensors are among the most widely used for environmental monitoring. They work by measuring electrical changes that occur when the biological element interacts with the target substance. These sensors are highly sensitive and can detect even low concentrations of pollutants, such as heavy metals or pesticides in water. Their portability and ease of use make them ideal for fieldwork. Electrochemical biosensors have revolutionized how we monitor water quality, providing quick and reliable results. Optical biosensors use light to detect environmental contaminants. When the target substance binds to the biological element, it causes a change in the way light is absorbed or emitted. This change is detected and converted into a signal. Optical biosensors are especially useful for monitoring air quality and detecting gases or volatile organic compounds. Their high sensitivity and ability to provide real-time data make them valuable tools for environmental scientists. Piezoelectric biosensors detect changes in mass or mechanical vibrations. When the target substance binds to the biological element, it causes a change in the sensor's mass, which is then measured. These biosensors are often used for detecting pathogens or toxins in water and soil. Their ability to sense minute changes makes them highly effective for environmental monitoring, especially in detecting biological threats. Biosensors play a vital role in monitoring water quality. They can detect contaminants like heavy metals, pesticides, and pathogens quickly and accurately. Traditional water testing methods can be time-consuming and require laboratory analysis, but biosensors offer real-time results on site. This allows for immediate action to protect public health and the environment. Biosensors are now widely used by environmental agencies and researchers to ensure safe and clean water supply. Air pollution is a major concern in many cities worldwide. Biosensors are increasingly used to monitor air quality by detecting harmful gases and particulates. These sensors can identify pollutants like carbon monoxide, nitrogen oxides, and volatile organic compounds. Their ability to provide continuous real-time data helps authorities respond quickly to pollution events and protect public health. Biosensors are making air quality monitoring more accessible and efficient than ever before. Soil health is crucial for agriculture and ecosystem stability. Biosensors are used to detect contaminants in soil, such as pesticides, heavy metals, and pathogens. By providing rapid and accurate data, biosensors help farmers and environmentalists make informed decisions about land management. These sensors are also used in remediation projects to monitor the effectiveness of soil cleanup efforts. Their portability and ease of use make them valuable tools in the field. Pathogen detection is another important application of biosensors. These devices can identify bacteria, viruses, and other harmful microorganisms in water, soil, and air. Rapid detection of pathogens is essential for preventing disease outbreaks and protecting public health. Biosensors offer a faster and more efficient alternative to traditional laboratory methods, making them indispensable in environmental monitoring and public safety. Heavy metals like lead, mercury, and cadmium pose serious risks to human health and the environment. Biosensors can detect these metals at very low concentrations, providing early warnings of contamination. Their sensitivity and specificity make them ideal for monitoring industrial sites, agricultural runoff, and drinking water sources. By enabling rapid detection, biosensors help prevent long-term environmental damage and health hazards. Pesticides are widely used in agriculture but can contaminate water and soil, posing risks to ecosystems and human health. Biosensors are designed to detect specific pesticides quickly and accurately. Their use in environmental monitoring helps ensure that pesticide levels remain within safe limits. By providing real-time data, biosensors support sustainable farming practices and protect natural resources. Organic pollutants such as industrial chemicals and pharmaceuticals can be harmful to both the environment and human health. Biosensors are capable of detecting these substances at very low concentrations. Their rapid response and high sensitivity make them valuable tools for monitoring water and soil quality. By identifying organic pollutants early, biosensors help prevent environmental degradation and support regulatory compliance. One of the biggest advantages of biosensors is their ability to provide real-time data. Unlike traditional methods that require samples to be sent to a lab, biosensors deliver immediate results on site. This allows for faster decision-making and more effective responses to environmental threats. Real-time monitoring is especially important in situations where quick action is needed to prevent harm. Modern biosensors are designed to be portable and user-friendly. Many devices are handheld and can be operated by non-experts in the field. This portability makes biosensors ideal for on-site environmental monitoring, especially in remote or challenging locations. Their ease of use ensures that accurate data can be collected quickly and efficiently, supporting timely environmental management. Advancements in technology have enabled biosensors to be integrated with wireless communication systems. This allows for remote monitoring of environmental conditions, even in hard-to-reach areas. Data can be transmitted in real time to central databases or mobile devices, enabling continuous surveillance and rapid response. Wireless biosensors are transforming how we collect and manage environmental data. Biosensors generate large amounts of data that can be analyzed using advanced data analytics tools. By integrating biosensor data with analytics platforms, scientists can identify trends, predict environmental changes, and make informed decisions. This integration enhances the value of biosensors, turning raw data into actionable insights for environmental protection. Biosensors are increasingly used as part of early warning systems for environmental hazards. By detecting contaminants quickly, these systems can alert authorities and communities to potential risks before they become serious problems. Early warning systems are essential for protecting public health and minimizing environmental damage, especially in areas prone to pollution or natural disasters. Environmental regulations require regular monitoring of air, water, and soil quality. Biosensors make it easier for organizations to comply with these regulations by providing accurate and timely data. Their use supports transparency and accountability, ensuring that environmental standards are met and maintained. Biosensors are becoming a standard tool for regulatory compliance in many industries. Traditional environmental monitoring methods can be expensive and labor-intensive. Biosensors offer a cost-effective alternative by reducing the need for laboratory analysis and specialized personnel. Their ability to provide rapid, on-site results lowers monitoring costs and makes environmental protection more accessible to a wider range of organizations and communities. Recent advances in technology have led to the miniaturization of biosensors. Smaller devices are easier to deploy in the field and can be integrated into portable monitoring systems. Miniaturized biosensors maintain high sensitivity and accuracy while offering greater flexibility for environmental monitoring applications. This trend is making biosensors even more practical and versatile. During environmental disasters such as chemical spills or floods, rapid assessment of contamination is critical. Biosensors can be quickly deployed to affected areas, providing immediate data on pollutant levels. Their speed and portability make them invaluable tools for disaster response teams, helping to guide cleanup efforts and protect public health. Many environmental monitoring sites are located in remote or inaccessible areas. Biosensors equipped with wireless communication can transmit data from these locations in real time. This capability ensures continuous monitoring, even in places where traditional methods are impractical. Remote sensing with biosensors is expanding our ability to protect the environment on a global scale. Healthy ecosystems are vital for biodiversity and human well-being. Biosensors help monitor the health of ecosystems by detecting changes in water, soil, and air quality. Early detection of pollutants or pathogens allows for timely interventions to protect wildlife and natural habitats. Biosensors are becoming essential tools for conservationists and ecologists. Sustainable agriculture relies on maintaining healthy soil and water. Biosensors enable farmers to monitor nutrient levels, detect contaminants, and optimize resource use. By providing real-time data, biosensors support precision agriculture, reduce environmental impact, and promote sustainable farming practices. Their use is helping to ensure food security and environmental health. Biosensors are empowering citizens to participate in environmental monitoring. Community groups and schools can use portable biosensors to collect data on local air, water, and soil quality. This citizen science approach increases public awareness and engagement, while also providing valuable data for researchers and policymakers. Biosensors are making environmental monitoring more inclusive and collaborative. Despite their many advantages, biosensors face challenges in deployment. Issues such as sensor stability, calibration, and interference from complex environmental samples can affect performance. Ongoing research is focused on improving biosensor reliability and robustness. Addressing these challenges will ensure that biosensors continue to deliver accurate and dependable data for environmental monitoring. Researchers are constantly working to improve the sensitivity and selectivity of biosensors. Advances in nanotechnology and materials science are leading to more precise sensors that can detect even lower concentrations of contaminants. Enhanced selectivity ensures that biosensors respond only to the target substance, reducing false positives and improving data quality. Calibration is essential for maintaining biosensor accuracy. Regular calibration ensures that the sensor's readings remain reliable over time. This process involves comparing the biosensor's output with known standards and making adjustments as needed. Proper calibration is especially important when biosensors are used in changing environmental conditions. For ongoing environmental monitoring, biosensors must be durable and capable of long-term operation. Advances in sensor design and materials are making it possible to deploy biosensors for extended periods without frequent maintenance. Long-term monitoring is crucial for tracking environmental trends and assessing the effectiveness of pollution control measures. Internet of Things (IoT) is revolutionizing environmental monitoring by connecting biosensors to networks of devices. IoT integration allows for automated data collection, remote control, and real-time alerts. This connectivity enhances the efficiency and effectiveness of biosensor-based monitoring systems, making environmental protection smarter and more responsive. As biosensors become more connected, data security and privacy are important considerations. Protecting sensitive environmental data from unauthorized access is essential for maintaining trust and ensuring compliance with regulations. Secure data transmission and storage are key components of modern biosensor systems. Future of biosensors for environmental monitoring is bright. Emerging trends include the development of multi-analyte sensors that can detect multiple substances simultaneously and the use of artificial intelligence to interpret complex data. These innovations will make biosensors even more powerful tools for protecting our environment. Biosensors are playing a growing role in monitoring the impacts of climate change. They can track changes in air and water quality, detect greenhouse gases, and monitor ecosystem health. By providing timely and accurate data, biosensors support climate research and help guide mitigation efforts. Biosensors are valuable educational tools for teaching students about environmental science and technology. Hands-on experiments with biosensors help students understand concepts like pollution, data analysis, and scientific inquiry. Educational programs that use biosensors inspire the next generation of environmental scientists and innovators. Industries such as manufacturing, agriculture, and energy use biosensors to monitor environmental impacts and ensure compliance with regulations. By detecting pollutants and tracking emissions, biosensors help companies minimize their environmental footprint and operate more sustainably. Their use is becoming standard practice in many sectors. Collaboration between organizations, governments, and communities is essential for effective environmental monitoring. Biosensors facilitate data sharing by providing standardized, real-time information. Shared data supports coordinated responses to environmental challenges and promotes transparency in environmental management. Open-source biosensor platforms are making environmental monitoring more accessible. These platforms allow users to build and customize their own biosensors, share designs, and collaborate on improvements. Open-source initiatives are driving innovation and expanding the reach of biosensor technology. Accurate environmental data from biosensors is informing public policy decisions. Policymakers rely on biosensor data to set regulations, assess risks, and allocate resources. The use of biosensors is helping to create more effective and evidence-based environmental policies. Biosensors are being integrated into global environmental monitoring networks. These networks collect data from sensors around the world, providing a comprehensive picture of environmental conditions. Global monitoring supports international cooperation and helps address transboundary environmental issues. Artificial intelligence, AI, is enhancing the capabilities of biosensors by automating data analysis and interpretation. AI algorithms can detect patterns, predict trends, and identify anomalies in environmental data. This synergy between biosensors and AI is making environmental monitoring smarter and more proactive. As biosensors become more widespread, ethical considerations must be addressed. Issues such as data privacy, informed consent, and equitable access to technology are important for ensuring that biosensor deployment benefits everyone. Ongoing dialogue and responsible practices are essential for the ethical use of biosensors in environmental monitoring. Conclusion: biosensors are revolutionizing environmental monitoring by providing rapid, accurate, and cost-effective data. Their applications span water, air, and soil quality, disaster response, and more. As technology advances, biosensors will become even more powerful tools for protecting our planet. By embracing innovation and collaboration, we can ensure a healthier, more sustainable future for all. Thank you for joining us on this journey into the world of biosensors for environmental monitoring.